Welcome to lesson number 1, moles and molar mass. Our lesson objectives: determine the number of atoms in a molecule as well as calculate the molar mass of a substance. So as we go through this unit, we're going to learn the language of chemistry and how to write chemical formulas as well as chemical reactions. So this study of stoichiometry is the study of the amount of reactants, the things that we start with, and then the products, the things that we end up with in chemical reactions. So another way to put it is it's the study of chemical recipes that we use. And in order to understand these chemical recipes, we need to understand how to write and how to break down chemical formulas. And so we have a chemical formula like down here. We have these little numbers called the subscripts, and they represent the number of atoms that we have in that formula. And we have the big number out in front, the coefficients, which represent the total number of molecules or compounds that we have. So let's break it down. If I wanted to figure out how many of each type of atom I have in this chemical formula, what would I do? Well, the first thing to notice is that when there's not a subscript, there's an unwritten 1 there. So since there was nothing here for the P, it means I have only one P. And let's look at this parentheses here. So it says PO4, and it's in parentheses, and there's a 2 subscript after that. That means I have 2 PO4s. 1, 2. And so if I want to figure out just right now how many P's and how many O's do I have in those 2 PO4s, I have 2 P's and 8 oxygens. So 2 P's and 8 O's. Looking at the CAs, there's a 3 here. What does that mean? It means I have 3 calciums. And so, not looking at the 3 out in front right now, in one compound, CA3PO42, I have 3 calciums, 8 oxygens, and 2 phosphorus. So what does the 3 out in front mean? That means I have 3 of those compounds. So I have 3 of all of this. Or I can just rewrite the chemical formula 3 times. 1, 2, 3. So how do I figure out how many then I have of each of these atoms? Well, I could do all this and add them up, or there's an easier way. And what we can do is simply this. So we'll start with oxygen first. I have 4 oxygen times 2 gives me 8. 8 times 3 gives me 24. For the phosphorus, 1 times 2 is 2. 2 times 3 gives me 6. And lastly, we have 3 calcium times 3 gives me 9 CAs. So let's see some more examples. Let's figure out the number of atoms of each type. So for nitrogen, there's an unwritten 1 here, but I also have another nitrogen over here, so there's another unwritten 1. So 1 plus 1 gives me 2 nitrogens. For the hydrogens, I have 4, and for oxygen, I have 3. Next example, for aluminum, I have 2, and then again, we have this parentheses thing here. We have SO4, and I have 3 of them, so I have 3 SO4s. So again, it means I have 1, 2, 3. So if I want to count the number out, I have 2 aluminums, I'd have 1, 2, 3 sulfur, and I have 4, 8, 12 oxygen. Or the simple way of doing it is 1 sulfur times 3 is 3, and then 4 times 3 is 12. And then looking at the example below, for aluminum we have 3 times 2 gives me 6 aluminum. For the sulfur, 1 times 3 is 3, times 3 gives me 9 sulfur, and then lastly, 4 times 3 is 12, times 3 gives me 36. Let's check your understanding. Can you determine the number of atoms in a molecule or compound? Now let's talk about the mole, and we discussed this already in class. The mole is a unit that measures the amount, the number of particles of a substance, and the abbreviation for mole is MOL. 1 mole is equal to Avogadro's number, which is 6.02 times 10 to the 23rd particles, or things. So, as we discussed in class, the mole is essentially a way of packaging up a lot of small things like atoms. 1 mole is equal to the mass of the chemical formula that we have in grams. And this is a way that we can quantify a mole of a substance in the lab using a scale. So if you think about it, we do this in everyday life. We package up things. So instead of saying we have 12 eggs, we say we have 1 dozen eggs. It's a way of packaging up a lot of a substance into one bigger unit. So 1 mole of eggs would then be equal to 6.02 times 10 to the 23rd eggs. That's a lot of eggs. So for example, if I said I have 3.5 dozen roses, that would mean I have 3.5 times a dozen, which is 12, which is 42 roses. So if I said I had 3.5 moles of roses, it's just simply 3.5 times the value of a mole, which is 6.02 times 10 to the 23rd. So the answer would then be 2.1 times 10 to the 24 roses. Again, a very large number of roses. So what is this molar mass? It's the gram formula mass. It's the mass of the chemical formula in grams. And we'll use the abbreviation GFM. So it's the mass of the formula expressed in grams. It is equal to 1 mole. And the units for molar mass or gram formula mass is grams per mole. So it's the amount of grams per 1 mole of that substance. And the elements, their molar mass, or their gram formula mass, is reported on the periodic table. So the mass that's on the periodic table is the molar mass of that substance. So how do we calculate that out? First thing you do, count the number of atoms in the chemical formula in your compound. You're going to look up the mass of each of those atoms on the periodic table, and then you're going to multiply the mass by the number of atoms that you have. And once you add all those up, that's the total mass. That's the GFM, the gram formula or molar mass of that substance. So let's see some examples. What is the molar mass of the element iron? So I locate iron, which is Fe, and the upper left-hand corner is the mass. So the mass of 1 mole of iron is going to be 55.8 grams per mole. We're going to round to nearest tenth always on the masses on the periodic table. So what does that mean? It means for every 1 mole of iron, I have 55.8 grams. What is the molar mass of copper? I locate copper. Here it is. And so the molar mass of copper to nearest tenth is 63.5 grams. Again, I have 63.5 grams for 1 mole of that substance copper. What about for compounds? Well, now we're just going to add them all up. So what is the molar mass of water? So water is H2O. So I have 2 hydrogens. Each one is 1. So 1 plus 1 is 2. And then oxygen round to nearest tenth is 16. So 2 plus 16 is going to give me 18 grams per mole. Again, because water's chemical formula is H2O. So I need 2 hydrogens, each with a mass of 1. What is the gram formula mass of calcium chloride? Well, calcium chloride is CaCl2. So 1 calcium is 40.1 grams to nearest 10. And then we have 2 chlorines. Each one is 35.5 to nearest 10th. So 35.5 times the 2 chlorines I have, plus 40.1 for the 1 calcium, gives me a gram formula mass, or molar mass, of 111.1 grams per mole. So if I had 1 mole of calcium chloride, the mass would be 111.1 grams. And that's something that I could mass on a scale in the lab. So let's check your understanding. Can you calculate the molar mass or gram formula mass of a substance? At this point, you should be able to determine the number of atoms in a molecule, as well as calculate the molar mass of an element or compound.